The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, wherever you are in the country. It's Mark from SolidCAM. We'll be doing our 30-minute free training for SolidCAM Live today. With me, as always, is Kevin Rankel. Hey, Kevin.
Hey, how's it going?
So today, I thought we would review something that has come up a few times. And as always, whenever there's one thing you want to do with SolidCAM, there's probably a bunch of ways to do it. So we're going to cover today a spiral pocket. Spiral pocket, basically, you're probably looking for a really good finish on the bottom of your pocket. How do you get that to be a nice concentric spiral? There's actually 3 to 4 ways, depending on what you're looking for to do it. But right off the bat, the 5th way that would come right at the top of your head, if you're familiar with SolidCAM, is probably toolbox cycle. Toolbox cycles, usually there's a cookie cutter, bare bones version of a toolpath that you can look for here. And there is one called spiral pocket. See if I can grab that one. There we go. Okay, spiral pocket. Problem is with spiral pocket is in order to get this very simple toolpath to generate, you need a nice circular pocket. So that means that when I choose this floor here, it might actually let me go all the way through to the end, but let me just start grabbing some stuff here as if I'm going to finish this. So I'll just grab my tool. Levels are okay, technology, whatever it is, and then green check mark. Geometry should contain only round chains. So the spiral pocket only works when you have this nice circular pocket. So right away, that's the first thing to discuss with spiral pocketing. So let's say you do have this kind of, I guess this is officially called an oval shape, or just a square pocket, or any kind of irregular pocket that is not perfectly circular. How can you still get a spiral in that pocket? Well, you've got many different ways, and the way to think of it is you're looking for something that needs to morph to the shape of the pocket. So we're looking at something that might be 3D in nature, and that's pretty much the 3 toolpaths I'm going to look at. We'll start with milling and then 3D milling. So 3D milling is, if you've ever used it before, it's kind of the precursor to 3D iMachining. And the way to really think about how to use this is it is a 3-dimensional pocketing toolpath. So when we want to use it, let's say just in that area, we're going to let it look at the target, and then we're going to use a working area to limit the travel of the tool. So I'm just going to go in here, working area, define, got my smart face turned on, so I'll just grab that edge there, and I'm just going to tell it to do it as an internal. So now we're just doing an internal 3D toolpath inside the pocket there. Let's go to tool, select, and I have my 1/2-inch flat end mill. Levels, top of target, we'll go down to this face right here. And then under technology, if I wanted to do roughing, like I mentioned earlier, it is a type of pocketing toolpath. It's just a 3D pocketing toolpath. So you've got your hatch and your contour there. But in the finish, you have spiral. So this is actually going to let us do a spiraling finishing toolpath. Go to data. And if this looks familiar, this is actually the exact same toolpath Kevin used in a previous, I think it was either tips and tricks, or it's just a kind of a tip of the day or some kind of video where we covered this previously. We're going to do this as a path type spiral, profile type arcs. Start, we'll go at the center at 0, and then we'll just go out to, my size of my pocket is, or size of my whole entire stock here is 6. I'll just leave it at 6. And then all of that, probably okay. Save like that. And let's just generate this. So it is centered around my origin. So now I actually have to choose my center. So we'll go back here, go to data, and pick the center of the spiraling toolpath. Oh yeah, okay. So that will be X3, Y3, and then it's probably 2.5, if I remember correctly. Click OK. And there we go. So we got our spiraling toolpath, and I can increase or decrease the step over, but essentially what we're looking for is a nice spiraling toolpath that starts at the center and goes out. And you can see that because that is an irregular shaped pocket, it's not that circular pocket that the toolbox cycle would have been looking for. It's still generating that spiral, but it has to kind of trim it at the ends there. And because this is a 3D toolpath, it's recognizing where to do the trim. It's trying to stay inside of that working area. So that's one way to get that spiraling pocket finishing on the floor there. And again, there's all the different parameters in there, but that's one way to do it. Now, let's take a look at the other ways to do it. And it still follows the same line. We're looking at some sort of 3D toolpath to help us out. So we'll go to another one that might be somewhat simple to do, is the HSS toolpath. In HSS, it's more surface-based, and we have all these options here to tell it which direction we want the tool to travel. If we want to get that nice spiraling toolpath, we could probably do it as a parallel to curve, choose a circle, sketch, and then get it to be parallel to that. But even simpler would be projection spiral. This is automatically going to generate a spiraling toolpath. It's just going to project it onto whatever surface I select. So in my geometry section, I'll just go surface, click on the bottom of that pocket there. It's projecting in the Z direction. So Z is right there. And in this case, unlike what we saw with the 3D milling, I can auto-detect the center and even auto-detect the radius that I'd like it to go to. So I'll start at 0, but I'll let it just figure out how far out to spiral, what that spiraling limit should be. Everything else on here is the same as what we would have seen with another HSS toolpath. We'll just choose our tool. Levels is just clearance area, so I'll just leave it as automatic. Parameters, we'll just do this step over 50 thou. And just like we saw with the 3D milling, when you're doing spiraling, your options are either clockwise or counterclockwise. Everything else about this is still HSS. So I don't have a working area to work with. I have gouge surfaces to check. So I'll just go enable/disable. We will trim and relink. And then my check surfaces, they'll just be the walls around that pocket. And to make it really simple, there's a button that says all faces adjacent to drive surfaces. So just the walls. Save and calculate. It auto detects all that for me. It's calculating that spiral. And we get.
Mark is kind of going through this too, or while it's calculating here. One thing I just want to throw out, since we are trying to do a circular spiral inside a square pocket, I would definitely come back and just do a finish pass around the outside to clean up those walls so you get a real nice finish. We're getting a nice spiral on the floor now. And then I would, like I said, just come back and do a profile operation around the outside in there to get that nice clean wall face.
Absolutely, yeah. This is really just for the walls. So with all the toolpaths that we're going to cover and we already covered, you're going to want to come back and do that perimeter pass. So in that case, what we could also do is we could actually do, let's just do this here, where we're doing just the check faces, check surfaces, I should say, just the walls, and I'm going to leave a little bit of stock on the walls. That way, it's even easier to clean that up. So just stock to leave on the walls, on the check surfaces, and then just recalculate, and we'll see that it pulls back from the wall a bit. Okay, and we can't really see it probably too much, but if I left more than 10 thou, we probably would see it kind of trim a little bit. But basically, that's what happens when you turn off the drive surfaces. When you're doing only check surfaces, now you can leave that material on the wall, and now we can go and do Kevin's final perimeter pass. We could do that with a profile, or we could do that with pretty much any other toolpath that just looks at the walls. You could do a finishing pocket, you could do a an iMachining, iFinish sort of thing. But basically, like Kevin said, we're just looking at the floor for now, because really the spiral only really applies to the floor. So we get that nice circular spiral there with HSS. If we had, I wouldn't say we didn't necessarily need to have a more complex part, but the other toolpath that could do the same sort of thing is HSM. It is also a 3D toolpath. So we'll just go 3D HSM. Spiral machining is one of the options in technology, and it basically works very similar to what we saw with 3D milling, but also a little bit from what we saw from HSS. It's based off the target, so I don't have to select anything there. I'll just go to my tool, and again, we'll just choose my tool 18, my 1/2 inch end mill. Under constraint boundaries, we can do created manually, and then we can actually just choose our constraint boundary on the outside edge there. I'm just going to use smart face once again, just to click on that face to get those edges. And now I have my constraint boundary. I'm working internally, very similar to what we saw with 3D milling. In terms of passes, we have to tell it the center, like we did with the with 3D milling. Although in this case, I didn't actually plug that in. I think it auto recognizes it. I'm not sure if it does that, but I didn't plug that in when I first tried this toolpath, and it seems to work. Minimum radius is 0. Maximum radius, I guess it calculated that oddball number for my part. So again, it's still a recognition toolpath. It's still looking at all that kind of stuff for me. 0 at the top. Let's say it only goes down this far. And then link, I have all the control here I want. I can do plunge ramping and whatnot. Just do save and calculate. And then we'll see again that it generates that, that morphing spiral. Or not morphing spiral, I'm jumping ahead here, but it's generating that spiral. Now, in terms of the step over, let me just make that similar to what we had with the HSS. And then we get that spiraling toolpath. And again, the walls would have to come back and done again. And in that case, we could also wall offset. We have the ability to plug in a wall offset and step away from those walls, and then we could do that final perimeter pass.
And one real nice thing about this spiral toolpath on the floor is you are going to get a really cool looking finish, but a very smooth finish because that tool is maintaining that constant contact with that material throughout the entire cut. Where traditional pocketing, if we were to come in here, we do a lap around, then it bumps over. We're engaging that cutter at 180 degrees angle of engagement, and you get a little bit of a, you can definitely see the marks there, and maybe just a little bit of a witness, or you can feel it in the surface, where when you're doing a spiral like this, like I said, you're in constant contact with that floor the entire time until we hit those walls, and then where it's going to bounce up and down.
Absolutely, yeah. Okay, so the last one I wanted to show is not necessarily a spiral, it's the morphing spiral from iMachining. So it's just to kind of cap off the idea of doing a spiraling toolpath, but very similar to the point that Kevin just made. You can still get that accuracy, you can still get that kind of cool look to it, but you're doing iMachining, so there's going to be a little bit on the corners that aren't going to look super spirally, but hopefully I didn't just invent that word, spirally, but it's 2D iMachining gives you, as we know, the morphing spiral. So let's see, let's unselect this face. I'm not sure why I grabbed that one. There's that face there. Tool. There's our tool. Now I'm actually going to switch this right to iFinish just to show how we can do that. So we got that there. Let's just keep this guy where it is. Those guys where they are. Okay. Under technology, I've jumped right to iFinish. So if I wanted to just do the finishing pass and get that nice floor there, I need to give it some rest information. Normally, this is a follow-up to a previous roughing toolpath, but since I don't have that, I'm going to kind of trick it a little bit and basically say I'm using that 1/2 inch tool. I left a floor offset of 10 thou, and like we've been doing, let's leave a wall offset as well. And now we should be able to calculate our toolpath. And by default, it goes to the contour only because most of the times we do want that nice little racetrack style toolpath. That gives us a nice racetrack kind of step over finish. Well, here we're looking for that really cosmetic look of the spiral. So I'm going to switch this to iMachining, and we'll see what we get. We get nothing. Okay. So let's see, what am I missing here? Again, I love how SolidCAM Live screws up when I did this exactly the same way before the call. All right, let's switch this to iRough plus iFinish, and we'll just do this guy here. Oh, okay. I'm doing this as the recognition style. So this is a good example. Anytime you try and generate with these new options here, this is looking at the stock. I've already used a couple of toolpaths to already finish that or essentially rough that out. So there is no material for that to remove. That's why it's not generating. So I'm just going to switch to the old style here. Again, I'll use my smart face just to grab those edges. And then I finish. We got those data there. Now it's not looking at the stock. Now it should just generate whatever toolpath I tell it to generate. And there it is. Okay. Let's take a look at this from the top view. So we get that constant engagement like Kevin was talking about. We get this spiral that actually doesn't stay circular. It actually morphs out. So this is purely what we talked about. I think we even talked about this last week. the morphing spiral of iMachining. You're getting this actual purely spiral movement here. This might actually look pretty cool. But then when you get to the corners there, you're going to get some arc movements. Maybe you can kind of consider like it does kind of continue the spiral a little bit, but it's not going to look like that continuous concentric spiral. So this is another way to do it, but it's not exactly that nice spiral that we were looking for. But it is one of the options you can consider when you're looking at doing a spiraling pocket. Does that make sense? Those 4 options there. Anything you want to add, Kevin? I mean, this is a unique finishing option, but with these 4 toolpaths, you eventually should be able to get the thing you're looking for in terms of the finish, right?
Yeah, absolutely. And one other thing to just kind of add to this is if you guys are looking for a facing operation, if you're just decking off the top of your part, trying to do a face mill operation, there is the spiral option in there. But
there is, yeah.
Remember, when you are doing a facing operation, it sees it as the faces are all open. So it's going to consider it as an open pocket per se, but you will get that spiral option in there as well.
Absolutely. Yeah, I guess I forgot that because we were doing an internal pocket, but Kevin's absolutely right. You can consider the face milling operation as a pocketing toolpath where the pocket is open on all sides. So we do get customers that are doing, let's say, a 3+1 part, and they're trying to use the facing option because they just literally just want to face the top of their part, but it gouges into their chuck or something, or their holder or whatnot. And that's because it doesn't look at that. It's looking at as the top face of an open edge on all sides. In that case, you might want to use pocketing or whatever. So that's exactly what Kevin's talking about here. It's open on all sides. So if you were to use it here, you can still get that spiral. Let's just use it here. I'm going to use the same tool. We'll go from, I didn't actually add any stock here. So from the top face of, top face of here. So at 0, let's add 10 thou. And then for the face depth, we'll just use the same face. So we get that 10 thou. Technology, there is a spiraling option. And then from there, let's see, percent of overlap. Let's overlap by a lot, just so we can get that really tight spiral.
And since it is based off of the smart technology, like we're just kind of run into with the iMachine, so it knows that that top is already done. So we're just switching it over to old school.
Yep.
There we go.
And there you go. So there is a spiral, but not sure if it's coming through cleanly on the go-to meetings. What I'll do is I'll just go and change the tool color. It is actually going over the edges. So let's change this color from yellow to maybe this standard orange that always seems to pop up. And you can see that it's going over the edges there. So it considers everything as an open edge, but it goes from the outside in, or I could, if I go in there, if I'm right, there should be a way to flip the direction, right, Kevin?
I don't think so. Because usually when we're facing, it's taking a pocket and marking those chains as open.
Yeah.
It always wants to start, but yep, there is the option.
There it is, reverse. Yep. So in this case, if it would make sense to do so, I mean, I do have a flat carbide here, so I probably could do that plunge in the beginning, but yeah, you probably wouldn't want to do that with a facing operation. But this is essentially a bare bones version of a pocketing toolpath, so you have that similar ability. But that is only really for the top face. And if you look at it again, it is a type of morph spiral. So it actually doesn't stay concentric. It just spirals its way out until it finishes all those faces there. So it does come out very similar to like a square with round corners kind of thing. But it is another way to do it. Okay, let's see if there are any questions today. Okay, so we do have a question from Steve. My part won't fit the pocket. How do I tell my tool to take an extra 2 thou on the walls? Okay, so if you wanted to overcut your pocket, so let's say we're not doing spiral pocket here anymore, we're just doing simple pocketing. So let's just go pocket. I think we covered this, I think we covered something similar to this, but to specifically answer the question, if you want to overcut in a pocket, you could draw a sketch obviously you could do that and then just set that sketch as your pocket, and then that automatically overcuts. But let's say you wanted to do it here. I believe in the pocketing toolpath, there is a way to do the modify geometry, right, Kevin?
Yep.
Yeah. So let's say we wanted to go that extra 2 thou that Steve's asking about. And if my notepad would, or my keypad would work for me, 0.002. There. No. Negative 0.00. Point 00. No. Negative 2. There is a way to do it with a negative offset. Now, if it doesn't exactly work here, let me take a look at another toolpath, because pocketing doesn't get all the fancy new options, but this guy should have something in there. Unless, did I make this metric somehow? I guess not, but so let's see, can I make this, let's just do 20 thou, just to prove the point. So levels, so from there to there, looks good. We'll do this contour style and we'll leave all that off the edges there. Okay. So we go back to geometry. I've added that negative 20 thou there. So I'm not sure if there's just some sort of number limit there. Let me see if I can make that like that.
I think it was your keyboard just messing with you.
Yeah, could be my fat fingers as well. I'm not gonna lie. Let's go to suppress that. And if we run this pocket, we should see a gouge on those faces. So that gouge is between 4/10 and 4 thou. So we're getting my orange color there. To really prove it, let's go even more of an overcut here. So I'm going to open that toolpath back up, and let's make that 100 thou to really overdo it. Okay, so you can see the lines moved in, and if we go into simulate, solid verify, so that should be completely red on the edges. There you go. I actually took out that wall, not just the wall, but a little bit of that floor as well, because I really overstepped it. So hopefully that answers your question, Steve. Basically, anytime you want to do an overcut, there should be a place to put a negative offset. Now remember, this is in the geometry section where I've chosen my geometry and I'm telling it to size that up by this negative number. That is not a wall offset. You are not able to put a negative in here because this is for the purposes of leaving material behind for a finishing pass. So if I were to put a wall offset here of, let's say, 10 thou, that allows me then to do a wall finish. Or if I left this at 0, I'm already finishing that wall, but I'm not able to put a negative number in there. Or am I now? Did they change that, Kevin? Can we put negative numbers now?
If they did, it would be news to me.
It'd be news to all of us, I think. But it would be pretty cool if they could, because then, I mean, that's what this inclusion is right here. That's what this whole lower section is for. It's basically allowing us to put that negative offset or even to modify the part a little bit. You can see that it says all chains. I've modified it on all sides. But if I went to each chain, now I can go in here and specifically choose each edge. So let's say we put this back to 0. So now all sides are at 0, and now I can go and actually choose. Let's say we choose modify offset of, actually I've never used this section before. It says apply all. Is that to the individual
chain?
Is it? Oh, I guess I only have the one chain, yeah. But you could see down here that if I had open edges, I could do the individual edges and tell it how much to move out from those edges. So there's another way to do that as well. If you wanted to kind of go further out certain open edges and then other ones you want to stay a little closer.
Now,
but
one other way I would like you to show, Mark, is if we did this in a profile operation and let's say the part didn't fit, so we need to maybe not just rerun the entire pocketing path, but if we were just to kind of go back through and rework just that wall only, or those walls only.
So let's bring this pocket to size. Let me just bring this pocketing operation back up. So set that to 0. This guy is at 0. That's it. So like Kevin said, so now let's see if we need to just bring those walls to size. That actually is a little easier because when we go to profile, we have the ability to add a negative offset without any kind of special tricks or anything like that. Okay, so let's just use contour 3. We'll use that same tool. Okay, so as is, this is going on the left side of the chain. Let me just make sure that that chain was in the right direction. Pretty sure it is. No? Okay. Yeah, so if I say left side of the arrow, that's on the inside of the pocket. So we're getting the walls done with climb milling. And it's the same sort of thing as what we saw before. If I wanted to do an offset on the walls, I'd have to turn on rough, and then I'd have to put a positive number in there. To overcut it though, let's say to bring it to size like Kevin's saying, we go to the geometry button in the technology section, and that gives us very similar to controls of what we were just looking at. It actually, I think this started here, and then they incorporated this on the pocket side of things. So it all starts here. This offset could be either positive or negative. So if I wanted to do that negative 100th thou, I can actually do it here. And you can actually see what you're about to do. So I've done an overcut of 100th thou. We can actually visually see it there. That represents my tool. I'm overcutting. Now I can come in here and actually, I guess save and calculate related doesn't go backwards. So let's bring this guy up to size as well. And then we'll just run this toolpath in simulate. And I'm just going to step through it just to see what we've done. So there's my pocket, comes in. I guess I had the arc in going on. And then if we take a look at that, and if it's not showing up too well, let's go to hybrid mode. So you can see I'm actually doing that 100th thou overcut. Is that what you wanted to show, Kevin?
Yep.
And there you are. So that is a good way to do a modification to the geometry. So again, that modify, either in the profile or the pocket that we were looking at, that's to modify what the final result should look like. Anytime you see wall offset, it's referring to how much material to leave behind for a finishing pass. But anytime there's a modify, that is to change what the actual geometry is, what it should be at the final version of it. So in this case, I'm tricking SolidCAM into thinking that the final version of that wall is that 100th thou overcut. It doesn't update the target though, and that's why we're still getting that kind of, let me just bring this up here. We're getting that gouge check option here. We're getting that gouge of the wall there because it thinks that the original target is what the final version should look like. But in essence, what we're doing here is we're overcutting for a reason. So this is showing us that we're doing that overcut, if that makes sense. Looks like we're close to the end. So if you have any questions, plug them in real quick in the questions panel in the GoToMeeting chat, and we can get to it real quick before the end of class today. If not, then you can always email us your questions, either using Kevin's email or my email that Kevin's going to put in the chat section real quick. And you can use that email to send us your comments, your questions, your suggestions for class if you want to see a topic covered. If you've got any parts that you don't mind sharing in SolidCAM Live, sharing on YouTube, we can see that part live. We can work on it together. If you've already programmed the part, you want to see how we can kind of trim it up a little bit in terms of cycle time, or maybe even just ease of programming, we can cover that as well. You can also use that email for personalized training. I bring this up every class because personalized training is a great way to almost accelerate your use of SolidCAM, because there's a lot of us, myself included, that learned SolidCAM just by trial and error, just got in there, started using it, and figured out how to use it because it's a very easy software to learn, very easy software to use. But there are little tips and tricks like we've covered in SolidCAM Live, like Kevin's covered in KevCam, like we've seen the tips and tricks videos that you might not fall on, you might not figure out on your own because maybe, you know, how it is in the shop. We need to get code on the floor. We need to get those machines moving. So we don't have time to click on every button to figure it out. But in personalized training, that's when you would learn those little tips and tricks. I don't remember a lot of the stuff that I learned only from the personalized training that I've got from Kevin or some of the other the seniors that I've worked with in SolidCAM, or even just Sydney. SolidCAM professor taught me some stuff every once in a while, every time I talk to them. There's always a new little thing that you don't pick up on your own unless someone's like, hey, if you hold shift and then do this, it opens up this thing, or something like that. There's lots of little tips and tricks inside of SolidCAM that you won't ever really discover unless someone shows you. And personalized training will bring that out in the course of programming your part or covering a topic. If you know anybody that can benefit from SolidCAM, give them our contact info or get them to contact us. And if they go to demo, you still get that $100 gift card until the end of the month, until we stop doing SolidCAM Live, or I don't know if this is still going to continue with KevCam, but promotion is a $100 gift card just for getting them into a demo. So if they get a demo, you get that card. If it goes to sale, no matter what time it goes to sale, you get that 20%, because that's a finder's fee that we provide to you just for helping us to get someone using SolidCAM. Like I said, we are continuing this until the end of the month. We're doing it every Monday and Friday. So as of today, this is Monday's class. We'll be doing this on Friday the 21st, same time, 2 p.m. Eastern time. You have until then to use that email to send me your parts, your questions, your comments, your suggestions. If you like us, if you don't like us, let us know. We can change the remaining classes to fit your need for information. Because remember, this is all for you guys as the users of SolidCAM. It would not make any sense for us to just kind of sit here and go, okay, here's how you do a pocket, here's how you do a profile. We want to show you guys what you want to see. So use that email, send us suggestions, send us questions, send us your parts if you can, and we want to make sure you guys enjoy using SolidCAM. But for today, we'll end it here. Stay safe, keep your family safe, keep busy. We'll talk to you guys on Friday.
All right, see you guys.